Another paper, paper number 727. This study, through this paper, the study finds the influence of nominal maximum aggregate size, gradation, binder, performance criteria for the dense graded bituminous mixes. Again, it is the same thing. If you use the proper mixed material, proper gradation, proper performance criteria is judged, then the performance definitely gets better. All three papers which are being presented today gives one message to the field engineers. With little extra input of the cost, we can have pavements with a more satisfactory results for a longer period. With a proper working, with a proper mode of execution, with the same expenditure, you can give to the society a better performance, longevity of payment. These are the two conclusions which I could draw from these three papers. But my other learned friends who will be presenting their papers, will still elaborate further. Since we have been given 1.5 hours, so for all three papers we can devote 20 minutes each to each of the authors, and balance time can be utilized for your question and answer session. So we can start right now. We take up with the paper number 729, 29 at the first is. Please move ahead. Who will present? 729. Stop clapping. Stop.
Chairman of the session, Shri Mahesh Kumar ji, co-chairman Shri Guru Vittal ji, uh, other authors including Professor Ankit Gupta, Professor Nikhil Sabu, and uh, Professor Raju, and student from IIT BHU, all the delegates, ladies and gentlemen, good morning to all of you. And it is my privilege that I am presenting this paper from IIT Roorkee to all of you. This paper is basically the starting work of a PhD student, Preeti Rai. So, under the guidance of myself and Professor Nikhil Sabu, and this is the first part of the PhD in which we have tried to find out the effect of the prolonged aging on the material, especially the modified and unmodified bitumen. And in the second part, we have done rather the repeated recycling of the materials. That part, of course, is not the in the scope of this paper that we may be presenting next year. But this year we are presenting the first part, that is the prolonged aging. I have divided the contents into different heads like introduction, need of the study, methodology, materials and characterization, results discussion, and conclusions. So, as we know that the bitumen is the most important part of the road construction when we are going for the flexible pavements, and natural aging takes place just like the human being. Aging takes place for the bitumen also with the time. Uh, if you see the faces of different persons, maybe especially you can observe those persons who are coming in IRC for the last 20 years continuously, the aging is taking place, including me. I joined the first IRC session, I think, in 1990. So for the last 34 years, I have attended about 25 IRC sessions. So changes are taking place. Similarly, the changes are there in the vitamin also, and it involves a combination of volatilization, that is the chemical oxidation, and polymerization. And we know that the aging is of two types: short-term aging and the long-term aging. You can see here the short-term aging takes place when the material is being heated, material is being uh, uh, mixed with the aggregate, and then it is put for the compaction. Till that time, it takes place for the short-term aging. After that, it is the long-term aging with the uh, effect of weathering over the road because of the sun, because of the rains, because of the air. All these things are part of the long-term aging. You can see here. So a binder with higher aging resistance is highly desirable for the construction of long-lasting and durable pavements. And incorporation of polymer modifiers has been found to be slowing down the aging effect. So, but there has been a question among the researchers, among the field engineers, that whether in the prolonged aging, the effect is to be seen for the modified binders, whether it is the same effect, whether it is the process is the same or different. So on the prolonged aging, limited research has been done in the country and abroad also. Mainly we have been doing for the short-term aging, we have been doing the RTFOT tests, and for the long-term aging, we have been doing the PAV test. Many times PAV is not available in the labs, so we have used another method which is also being used by the researchers in the world. It is known as the USET method. In this, for the short-term aging, we are not taking the RTFOT. We are using the USET method for 50 minutes. We are putting it at 150 degrees centigrade with the film thickness of 0.3 mm. So you can see the photographs. It is being done like that. Then it is showing you the short-term aging binder in the first photograph. In the second, it is the inside view of the oven during long-term aging. And you can see here, these are the materials which we have used for the unmodified binder. We have taken VG30. For polymer modified asphalt binder, we have taken PMB 8210. Basically, in the market, by the commercial name, PMB 8210 is not available. The numbers we have given based on the testing on the DSR by finding out the high PG temperature. So high PG temperature in this case was found to be 82, and -10 is the lower temperature which has been taken. This number comes from the bendiometer. So you can see here that for the extended aging durations, we have taken VG30 for 40 hour, 150 hour, and 200 hours. For PMB 8210 -10 rather, we have taken 40 hours and 100 hours. For the 100 hours of PMB 8210, the similar condition of the aging comes in between 150 hour to 200 hour in VG30. So this is the methodology which we have taken. We have taken, as I said, VG30, PMB 82 -10, and short-term aging done for the VG10 as well as for the PMB 82. Then we have done both the agings we have done using the USET. And after that, we have done the aging for 40 hours, 200 hours, 40 hours, and 100 hours for PMB. And these are the tests which we have conducted: penetration, softening, rutting factor, that is G star upon sine delta, fatigue factor, that is G star into sine delta, MSCR, and linear amplitude sweep test, that is LAS. And after that, we have assessed the effect of extended aging. The photograph is of DSR. You can see here that how the penetration value is varying. The variation is exponential, you can see here, and it is almost same in unmodified and modified binder. For the softening point, it is not exponential, it is rather linear. You can see here the effect is also the same in both. Then we have tried to find out the effect of extended aging on rheological properties. So you can see here rutting and fatigue factor. Rutting factor is G star upon sine delta, and fatigue factor is G star into sine delta. And these values are shown here. And you can see here that the value is G star into sine delta is more for the modified binder, which means that uh, it is better in that case. And for the fatigue factor, you will find again it is less because it should be less. So for modified binder, fatigue factor is less. This is showing you the rutting factor aging index and fatigue factor aging index. You can see here these values when the aging is less. At that time, there is not much difference between the modified and unmodified binders. But as the aging is going on, the effect is visible there. For the modified binder, the aging is less. Then we have JNR, which is the indicator for the rutting factor, and you will see here it is also showing that for the modified binder, the JNR is better. We have done it as you can see for the short-term aging, then 40 hour, then 150 hour, then 200 hours for the unmodified binder, and 40 hour and 100 hours for the modified binder. Then we have seen the fatigue life. Fatigue life is again more, if you see here, that it is going up to 10 to the power 10, e to the power 10 for modified, while for unmodified it is going as e to the power 8 in this case. And at the lower shear strain, you will find the age is more. As the shear strain is increasing, the life is also coming down. So this is showing you the conclusions that the penetration value is decreasing with aging time, while softening value increases with aging time regardless of binder type. Rutting mode is getting age. The rutting is increasing, but the fatigue starts increasing. This is there in this case also. The PMB consistently shows that GNR values with VG30 at all aging levels indicating better resistance, rutting resistance, and the LAS test, which was also done, showed that the fatigue life of bitumen improves after aging. So this is, as I said, is the preliminary work which we did for the PhD of Preeti Rai, myself and Dr. Nikhil Sabu. We did this under our guidance. This work was being done, and then she has done another part, that is in the real life there are many roads which are getting aged and we are doing the recycling. But again the question comes that after recycling again you are using it for 10 years, then what will happen? You have to remove that material or you can use that material again. So we have done recycling also. Of course, it is not part of this paper, so I am not showing the slides. But I can tell you that it is getting recycling maybe 2 times, 3 times, because in our country there is a lot of uh, scarcity of the aggregate. We are not getting the aggregates. We come from Uttarakhand. There also there is a ban on lifting of the aggregates nowadays. In Uttar Pradesh, there are almost nil quarries, so they are also dependent upon the Haridwar district or other districts of Uttarakhand. So it is the way we can utilize recycling for this purpose. And I am sure in the next IRC, we'll be able to give you that data. And I have another presentation in parallel session. So after in between the session, I will be leaving. So in that case, because the question hours will be in the last. So at that time, Dr. Nikhil Sabu will take the questions. He will be here up to the last. I will be leaving in between to make the presentation in the parallel session. Thank you.
Thank you very much, Dr. Praveen. We can go ahead with the next presentation. Please note that we have to conclude by 11 if I am not wrong. Since we have to include by 11, next presentation, please go ahead on the paper 726. Sir, 15 minutes at the most. Sir, 15 minutes.
Yeah, good morning and thank you, Chairman. Thank you, Co-Chairman. And good morning to Professor Praveen, Professor Nikhil, Professor Ankit Gupta, and Ms. Sadia. And good morning to all the dignitaries here. This paper was proposed by Sri Ravindra Rao Garu, the former engineering chief from Telangana Roads and Buildings. He could not be here because of some urgent reason. Otherwise, he wanted to be here and make the presentation. This paper is more of the data. The data speaks more than the words. This is a real field problem which we had considered. Whenever we make a test track, it will never fail. So what we did was we chose a section which is already constructed, never informed that it will be a test section, just examined it. So I will speak about the data now. And thanks to my other authors, Dr. Harshita, who recently graduated, and Professor Prashant Sahu and Ravindra Rao Garu. Yeah, this is not very new, but very important as well. Many people spoke about compaction, and it looks very simple, but at the same time, it is complicated. Lesser air voids at the beginning can create wonders. And then in APT also, they mentioned that air voids is one of the important parameters, so compaction should be done at the right time. Then one single most construction control is compaction. The main objective of this study was to find, initially after the road is constructed, we have certain air voids. What are its effects? If the air voids is quite high, what will happen? If the air voids is maintained at a normal, maybe around 7% or 6%, how does it behave? We had two different sections here. We selected two roads. One is Raigiri to Yadgiri Gutta. This is a pilgrimage, recently constructed road pavement. The other one is Hyderabad to Karimnagar, which is a heavy traffic road. And we selected only 2 kilometers from each road section. One was MDR, the other one a state highway, but expected traffic was more or less the same in both. These are the two new road sections. There was an overlay done or a resurfacing, whatever we call. 40 mm PC was done on road number 2, but road number 1 was a new road with DBM plus PC. Though we concentrated much on our asphalt layer, but the subgrade at Telangana state is quite good with 10% CBR and lot of importance is given for subgrade compaction. I think that created wonders. Yeah. Though it fulfilled all the requirement, the gradation was not as expected. The mid grading, it was a variation. And then all the Marshall parameters as per MORTH/MS2 or as per today's IRC SP 135/2022 was fulfilled. What we did was, we have heard of performance studies every 6 months, 4 months once, 3 months once, but we did something different here. From the date of construction, every month we collected the course, tried to find how the density varies or how the air voids reduces and how the bitumen behaves over time to assess the aging on the real field condition. So what are its impact due to traffic and what are its impact due to climatic conditions? This is what was assessed in the whole of this study, which took for more than 3.5 years. Yeah, visually, if you see, the road was good. Generally, we observe something called raveling. We don't worry much. But I was hearing to one of the lectures from my colleague's friend from Federal Highway. He was telling raveling was a failure. They consider this as one of the failures. But here we ignore it many a times. We see white patches along the wheel path and we ignore it. But actually, that is one of the major reasons for moisture damage. That is what we observed in this study. I will take you through this presentation to show you that. After some time, 3 years down the lane, we predicted that it may crack. And when we went and observed, there was cracking. But the cracking was not the routine bottom-up cracking. It was from the top, which is relatively new, though it was my PhD topic at Kharagpur. But even today, it is a new topic. The cracking starts from the surface and comes to the middle, maybe top 20 to 25 mm is what is critical. and then if it is ignored, it goes to full depth. So at 25 mm, they try to mill and do some patching out here. Though it was not along all the wheel path, some locations it was wherever the air voids was quite high. What we observed was the surface cracking or top-down cracking. We call it in short as TDC. It's not only the aging of bitumen, it is also the non-uniform contact stresses which causes this damage. Most of the cases, what we think is it is a circular loading, uniform loading. That is not true. It is non-uniform because of the treads itself. So when the surface binder becomes aged or it stiffens, this cracking is predominant. Yeah. When we measured, the air voids was somewhere around 7.5 to 8%, still within that MS2 specification, which says 92%. Also, MORTH specifies the same. And in another section, it was 7.1 to 9.1%, though 9.1 is not at all locations, but wherever using a random number, we tried to take the core, there were 1 or 2 sections with 9.1% air voids. Yeah, it is not to blame anyone. Everybody did the right work, but this cracking was something which was unexpected, not considered in any of our design. So we tried to measure the air voids variation. If I see the trend, yeah, it gives some trend, and there is a reduction in air voids over time with traffic, and there is an air voids reduction in the other section as well. Then we went after three years and again took some course to see whether the trend follows. Yes, it follows. But thanks to my colleague Akshay, he says that why don't we split it into parts and see it? So we try to split it and try to find the trend line. This is for road 1. Yeah, it showed a linear trend line. So let me see what happens with road number 2. It showed some trend line in the first 200 days, that is around 7 months. Then the trend changed. It became flatter and flatter. What happened to this first initial few days? Because of traffic, there was a secondary compaction. Though the aging was significantly high at the few days, the rate of aging started reducing because of that reduction in air voids. So I tried to compare the two. We can see that the slope was quite high in the beginning for road 1, and then it started streamlining and almost flattened by the end of 4th year. We had different equations for that. So initially it was 3 times higher, and then it became almost same as road 2, and then reduced by half and 1/4. So there is a change in the slope. However, it shows that initial compaction plays a very, very important role. So we tried to find, is there a moisture damage because of higher air voids? Yeah, it is known. Perception was there, and some of the data also proved it. But like any other doctors, we have to test it our own. So we tested and found that only 40% retention if there is air voids of around 12%. And that proved to be the same even when we did in the field. Yeah. So we tried to cut the core and did a Hamburg wheel tracking study. Why did we do this? I spoke about traveling. Will the rubber tire remove the aggregates? To our surprise and whatever we had observed, the fine aggregates was removed from road number 2 where the air voids was quite high. That was because the fine aggregate coated with bitumen was getting aged and drying it up. When the rubber wheel moves on that, it was just removing from the surface. So every bad thing also has an advantage. Because of this aging, the rutting did not increase, but there was a potential for cracking. So then we tried to extract the bitumen and test the bitumen. There was one thing observed. Many engineers keep claiming that there's a reduction in bitumen over time. So that was a perception. But when we tried to measure, there was really a reduction in bitumen. This will be a controversy. Yeah, we cannot just conclude by only one study. I think some more studies need to be done. And the reduction was to an extent of 0.9%. That's quite surprising. But the data is speaking. Yes, 0.9% reduction. That was because of removal of the fine aggregate. and that fine aggregate was 150 micron. 150 micron having more surface area coats the bitumen, and when that is removed, there was literally reduction in the binder content. So whether it was only on the top or full of the layer, yes, what we did was we slide this into two parts and then tested it. And also Shell Bitumen Handbook, they mention a lot about this aging, initial aging, which Praveen Saab mentioned, and then that is short-term aging, and then the long-term aging. But the rate of aging depends on the air voids. This is with an assumption that the air voids is 7%. But if the air voids is quite high, the rate of aging is different from what is shown in Shell Bitumen Handbook. It may not reach by 8 years, probably we'll reach it by 4 years. That is what our data showed. Yeah. So we try to find the G star by sin delta. That is one parameter has to be verified. So we chose G star by sin delta as a parameter to find what is the stiffness variation with respect to time. We found a similar trend where the initial stiffness was quite high and later on it became linear with respect to R1 and R2. So there was not much of variation. Even here we split into 200 days and tested. Yeah, initially there was variation and later on it showed a similar trend. So now if I compare between the air voids and stiffness, there is a correlation. Initially the reduction in air voids was significant. Similarly, the stiffness of the binder was also significant. Then it followed a linear trend. And so is the stiffness. When we tested at 64 degrees with 10 radians using the DSR, we could predict that around age of 4 years, it will reach a value to that of PAV. Even that NCHRP report 0954, earlier they were mentioning as it is between 6 to 8 years, but now it is 4 to 7 years. So road 1 was able to meet for 4 years, then the other road for 5 years. That's our prediction. And it also was validated in the observation where after 4 years, we could see that there were some initial cracks on the surface. And so was the combined index when we did the carbonyl and sulfoxide indices. Yeah, I think I mentioned about this, but I was waiting for this picture to come there. We sliced into two parts. And we found the bottom layer had 5.3% bitumen, that is our initial binder content, but the surface had 5% and 4.3% bitumen, which showed that there was reduction in the bitumen in the surface because of raveling. As I rightly said, I cannot conclude and say authentically because some more data is required and we have to continue with this study. Unless otherwise proven, it becomes only a perception. One data is not sufficient to conclude. And then the binder also became very, very stiff in the surface than at the bottom. We did the GNR study and it was shown that it is 0.49 at this surface, whereas it was 3.25 at the bottom layer. It was same as the fresh bitumen. So here are few conclusions which I would like to make. When the air voids is more than 8%, it is prone to moisture damage, and that was observed in one of the road sections. Then the Hamburg wheel tracking showed that there was raveling, and that was because of the surface aging. Then IRCT index was observed in indicated that lesser binder aging in R1. So it showed a higher CT index in road 1 than in road 2. Also from the sieve analysis, we could see that 150 micron was missing. I can understand the coarse aggregate missing because of the cutting of the coarse, but 150 micron missing is that because of raveling. Then the aging in R2 is faster than R1. Also, the projected data showed that G star value equivalent to PAVH binder after around 1800 years, 800 days. But for R2, it was around 4 years. And our prediction came out to be true because they have milled and resurfaced or milled and patched at few locations where there were cracking. It is not a bad construction, but some precautions should have been taken. I think now they are using 2% lime in whole of Telangana and the roads are lasting more than 5 years. Therefore, it can be inferred that well-compacted BC undergoes lesser raveling and better resistance to cracking. One recommendation we would like to make in this study based on the data which was collected every month, not biannually or so. that if the compaction is done to 94%, because today's equipment is good and it can even compact to the extent what we wanted, 94% with 6% air voids, we can increase the life of the pavement without increasing the binder content. There are two schools of thought. One school of thought says reduce the compaction effort in the beginning and increase the bitumen content. The other school of thought says bitumen is costly, so increase the density. I am from the second school of thought where I will say increase the density because bitumen is a cost. And I have put this slide because it was told by Wayne Jones, which was told in 1977. So we can keep reinventing the wheel. We learn from our mistakes. He mentioned that compaction efforts cost nothing, but the benefit is much, much more than what we have seen. And I want to end up with two observations that I made. You can observe these two pictures here. These are from two different locations. On the left side is what I observed in most of the field wherever I go. Most of us go behind the paver considering it to be Bharat and nobody behind the roller. But the same section, there were many people at the roller and many rollers were operated because there is somebody to look at them. So they were rolling up and down and then the density was well achieved. In the first one, the roller was sleeping, that roller operator, and only when we push him, he tried to roll it. So this was one observation, and I learned this from Dr. Kadiali, who said that engineer should not see, he should observe. One simple observation can give a great learning is what I feel. With this, I will end my presentation. Thank you for your patience hearing.
Next paper is good.
So good morning, everyone. Honorable Chairman, Vice Chairman, Professor Sridhar, Professor Nikhil, Sadia, and all the delegates and attendees here. So today we'll be discussing something about our paper, which is trying to investigate more about the Marshall mix design using some additional test. Okay, so the whole genesis of this study is a sponsored project for the from the National Highways Authority of India, which was initiated by Professor Nikhil, and then somehow we carried out this work. Okay, so the again going back to some ideas that Marshall mix design we have adopted in our mix design methodology for the asphalt mixes or the bituminous mixes. Again, that story goes back to something around 1935. The volumetrics is the core of the Marshall mix design, and we understand that this was being designed for a lower traffic at that time, 3 MSA, 1 MSA something. And nowadays we are doing the roads of 300 MSA, 500 MSA also. So whether this kind of Marshall mix design is sufficient, and again when we are using some different complex materials like wrap, sometimes fibers, sometimes various additives we are using, polymer modified binders, which was not being used in the 1940s or 30s when this Marshall was there. So still somehow we see that India is not like just following the lines of the Western country and adopting the super pave. We are still using the Marshall. So can we supplement our Marshall with some additional performance tests, which we normally talk about like rutting failure or a cracking failure, but we never do these kind of a testing for our Marshall mix design as a QC/QA process. Okay, we do some kind of a thing in the research project and then we present it on the diocese. We have seen some CT index, some rating value. Okay, but this is again not a part of our QC/QA process. So this is just an idea to at least think about that what can be some test which can be a part of the QC/QA process, and if yes, then what are the threshold values? Because those threshold values have to be decided on our experiences. It cannot be directly taken from the any of the country's specifications. So this is what we all know, that there are some distresses. Somehow we have seen that the moisture damage is a part of our QC/QA process, like the TSR value. So we are well uh, used to this fact that we do the TSR test. But rutting and the cracking, we again try to simulate these values with some air void, VMA value, but never, means as a QC/QA part, we do not have any test to check the rutting performance or the cracking performance. So this is what we have seen over the years, the bituminous mix design. We want a long lasting performance, a very big word. Still, we have seen that a lot of failures are occurring for various reasons. Okay. So what to do? So basically, this was the idea that can we have some benchmark threshold for the pavement industry for some new test, okay, which can be a part of this thing. So this is again just a whole chronology of the design process. Okay, so somewhere we see that 1935 to 1940 was the initial genesis of the Marshall mix. Western side has adopted a different kind of a mix method known as super pave. Still, we are doing with the Marshall. Again, there is no question on the understanding or the basic fundamentals of a Marshall. So we are not criticizing the Marshall, we are just supplementing the Marshall. So we are telling or we are suggesting that let us follow the Marshall and let us do some additional tests just to be have a more confidence on the mixes which we are creating. So this is what we have. There are four approaches which has been there in the literatures. Okay, so they say that do the Marshall, do some performance test. Probably this is the approach A, more conservative kind of a thing. But the approach B, C, and D, when you go towards the D, it becomes a more kind of a revolutionary kind of a approaches where they start saying that do not go ahead with the Marshall, don't need any volumetrics, only just rely on the performance. So just do the performance test. If your mixes are behaving well in the performance test, probably volumetrics is not so important then, because performance test is giving you a better idea. So this is how approach A to D is been there. This is something very critical. The whole point of this, that if you want to adopt any test, then what is that test? Because if you're thinking about a QC/QA process, then we need to be very sure that a test should be a simple test, because it has to be done on the field, probably by our uh, the engineers who are working on the field. They should also understand those tests. It should be quick, simple, reliable. The sample fabrication should be easy. All these things obviously cannot come in a one package. Okay, it is always a difficult thing that a simplest thing cannot be the most reliable thing. So somehow there is an optimization kind of a thing has to be followed. So this was one of the idea of selecting the test what we are proposing here to be one of the tests who basically tries to fit in all these points in an optimized way. Again, I'm not telling that this is the easiest method, but probably looking at to the optimization level, this looks to be a fit to us. So complexity, cost of test equipment, because if it's a part of a QC/QA process, it has to be in the laboratory of each and every contractor also. Repeatability of the test, fabrication. We have all seen that if you have to do the Hamburg, either you have to do it on the slab, or if not on the slab, then the 6 inches sample has to be casted, then properly make it in the 8 kind of a shape. Then only you can do the test. Take 20,000 cycles. So again, take 6 to 8 hours kind of a thing. So this needs to be looked upon that whether we really need this kind of a test or so. And again, it should have some kind of a correlation with the in-service distress. Like when I say rutting, so rutting means Hamburg. Okay, so Hamburg has a correlation because you can see that there is a kind of a wheel which has been moving. But if I'm proposing any other test, does it have that correlation? There are multiple tests which is available in the research field. But what has a better correlation with the field distresses, that also should be looked upon. So there are like these different tests are being there. Again, probably some more tests can also be added to these lists over the years, that the asphalt pavement analyzer, Hamburg is there, rapid shear rutting, stress sweep is there, ideal rutting is there, dynamic creep is there, high temperature IDT is there. So there are different researches has already been done. This has some good correlations also. Some has some advantages, some has some disadvantages. So with this, basically we have gone ahead with one of the tests known as the dynamic creep test. The lower side, the middle one. The whole idea behind this is that we want to go ahead with the samples which we are already casting. So Marshall samples can be directly used for this. So there is no any other need of a requirement of a different kind of a sample fabrication. Then I'll come to the next part, that is the cracking performance. Again, there are various things are available. Probably the most best fundamental test what we understand is the flexural beam fatigue test. But again, those who have done this flexural beam fatigue, they know the understanding of cutting the samples. So different one is there. We normally adopted the ideal CT. Again, the whole fabrication like the Marshall sample fabrication. And one of the equipment which is being used for this, basically a dynamic frame, can be used for the dynamic creep also. So again, one frame can do the rutting test also and can do the cracking test also. So you do not need to have two different equipments for the two different tests. So with this idea, we move forward. Probably I'll request Sadia to present the work because she was the instrumental in carrying out this work. Yeah, Sadia, please.
A very good morning to all of you. So, as sir told that we need some performance test and specification for the Marshall existing Marshall mix design. We need to complement our existing Marshall mix design with some of the performance test and specification. Going by the literature review in the US, various DOTs are there which are using different approaches, approach A, B, or C, or D, and with their specific performance test depending upon their weather condition, the requirement of the test. So they are basically on the using the super pave mixes. So we cannot use their specification directly for our Marshall mixes. So so this is the basically literature review for they use different approaches for different mix type and they gave their specification for different super mixes. So since in India we are using the Marshall mix design, so we try to come up with some Marshall specification which could add on to the IRC 111 for the requirement of the dense graded mixes. So in this we initially initiated with around 1500 Marshall specimens in which we considered two type of mixes and took five different type of gradation along with three binder which are commonly used in India, and we try to give five different compactive effort from starting from 35 to 110, just to simulate the primary and secondary compaction to which a road pavement will be subjected. Additionally, then we considered other type of mixtures as well, such as SMA and different type of aggregate type, so as to have a broad data set so that we can set our specification more confidently. So the total number of sample we made in our lab was around 5,000 samples. So this was a research methodology we adopted for each type of mix. As sir mentioned, we need to have some simple, quick, reliable, and easy test to be performed. So, as we are using the Marshall design, so we try to stick using the Marshall sample without the without the need of any further notching, cutting, or fabrication requirement. So, dynamic creep test is conducted in around 2 hours, which is used to calculate the rutting resistance of the mixture. In this, a dynamic load is applied, like how the wheel, like the load is coming and going. For a 1 second, the load is applied, and for the another second, the load is removed. So after the around 2 hours, the we have the initial height of the sample, and thereafter we note the final height, and we get with the help of the change in the deformation, we are able to calculate the permanent strain. So for the considered different design factors such as aggregate type, aggregate binder type. Okay. So, as we have calculated all the performance, we tried since we are following the volumetrics. So we try to calculate we try to find the correlation between the volumetric properties as well on the performance parameters. So the GMB and the VMA were found to be having excellent, better correlation rather than air void and VMA. So similarly, we try to find for the CT index. We did some statistical analysis doing using ANOVA, and as Sridhar Raju sir pointed, that the compaction can play a very important role in the design. So in the rutting, we found that compaction has a higher the F value denotes the its significance. All the factors were significant, but the higher the F value indicates the strong one, because if we choose the minimum one, all that could be the most conservative one, because if we choose the minimum one, all will pass. And if you choose with the see the alternative 5, the average thing, the mixtures, half of the mixtures will be discarded. So for the different approaches, we try to calculate, and based on the lab study, we are for the rating we have thought to proceed with the 80% reliability, because the payment initially will be subjected to primary and secondary compaction. However, for the CT index, we try to keep the criteria little stringent, because it will occur after few years of life. So we proceeded with the average value. However, we have made field test section near Ayodhya, Jagdishpur, and we will be verifying this value so that our initial threshold specification will be modified on the base of the field validation. And this is some performance diagram which can help us for the visual representation. So as IRC 135 and 139 specifically now emphasizes the importance of this performance test. But however, the some of the tests proposed have some limitation and challenges. So our study recommends two of the simple and reliable tests. However, keeping the threshold value suggested in our study, any mixture pass having more than the threshold value can be marked as problematic, and can be re-evaluated or the redesigned. And the one only suggestion, that as we have that the moisture test that the TSR like 0.8, or you can say 80%, two more tests can be added, like the permanent strain values, the minimum value and the maximum value, and for the CT index, the minimum value could be added in the code after the field validation part. So some few studies has to be is going on, still going on, and we will come up with the modified thresholds, and with a better threshold, and it will lead to the most cost efficient, durable, and long lasting payment. Thank you. That's all. Thank you.
Thank you, sir. We just listened three interesting presentations dealing with this asphalt mixes. The first paper by Dr. Praveen Kumar, this study highlighted how this aging is beneficial at lower strain and detrimental at a higher strain, and he compared different materials, PMB as well as VG30. The next paper, Dr. Sridhar, this is a very interesting paper, and I believe this subject is also very close to his heart. The manner in which he presented. Of course, he has highlighted that with an increase in compaction, we can achieve a better performance. The third paper by Dr. Ankit Gupta, this is also a very important paper, and I believe whatever the outcome of this study will be there, that will help us to improve our specification. That's what he has pointed out. They have pointed out. So this study is also very important, especially with regard to our the M voltage specifications are under revision. So I believe before they are printed, I think that they can their study will become concluded, and it will help the MORTH to come up with a improved specifications. So these were my brief comments, sir. We'll take up the yeah.
Now it's open for question answer. First, I'll request Mr. Nikhil Sabu to respond.
Okay, so thank you, sir. There is a question, probably it's related to the work of Sadia. wherein the comment states that the test specimens were compacted by applying compaction energy from 35 to 110 blows. Any specification test need to be standardized the test conditions such as sample, air void level, aging condition, etc. How do you justify varying the compaction level? So should I answer? Is it fine? Yeah. Sadia, should I answer it? Okay, I'll answer. So okay, so as you know, this study was sponsored by NHAI. So the idea was that we have to see that how the air voids and the volumetrics changes the performance. So when just after the compaction we have seen, and as was also indicated by Professor Raju, that let us say that the compaction is to a level of 92 to 94% of GMM, around 6 to 8% air voids. So we have to simulate the same at the same binder content. So first we decide the optimum binder content using the Marshall mix design process. At that binder content, we compact the mix. Now we compact the mix to different level to understand that how the air void varies. We also choose a very, very high compaction level so that we can see the terminal air void condition. So if you are aware that the terminal air voids ideally should not be less than 2%. Otherwise, the mixes will be subjected to shoving in the field, rutting in the bituminous mix. So in order to simulate all these conditions, because these conditions will finally affect the parameter which we are trying to propose using the dynamic creep test. And this is the reason we varied the compaction level to understand how the change in volumetrics will change the performance over a period of time. And we could have a plot of the performance model of these typical mixes which we use in Indian conditions. The second question is for ideal city test. What was the air void level and aging condition? So we compacted the sample to 6 to 8% air voids, and the sample was preconditioned after compaction to long-term aging as per ASTO protocol. So ASTO says that for long-term aging, because fatigue, it's not a fatigue cracking test first of all, it's a cracking tolerance test. So in order to simulate, in order to simulate the actual condition, so cracking ideally will occur only after certain repetitions has moved on the pavement is sufficiently aged, which means the binder is stiffened. And therefore, we compacted, after compaction, we subjected the mix to long-term aging as per ASTO protocol. And thereafter, the ideal city test was carried out. So these are the two questions with me, which I have answered.
So one of the question, I think Rajiv sir has mentioned about the lateral confinement. So while doing the dynamic creep, the lateral confinement, obviously, because in this test we are not giving any kind of a lateral confinement. So there will be some amount of the strain which will be going in the lateral side. There are two aspects in which we are discussing. One is we are already using the samples which has qualified the Marshall. So again, the flow values are within the permissible limit of the Marshall. The second thing, we have already verified this correlation of the dynamic creep with the Hamburg. So we have got that 92% correlation that the it again closed, because we assume that Hamburg is one of the more fundamental tests of the rating as compared to any other test. So we have done we have done a lot of samples with the same air void content, same gradation, same binder type with the Hamburg also and with the dynamic creep also. So it is giving us a 92% or 93% correlation. So with that idea, this is our assumption that if we are within the confinement limits of 4 as per the Marshall, we are not considering that flow value or that lateral movement in our permanent strain value. And again, the whole idea is to just set some threshold values, just initial threshold value. Again, these can be even refined with more data and more experiences. So this is just an idea to at least float some additional tests just to add on the Marshall. There is no any question on the credibility of the Marshall.
I'll just add to what you said, sir. So just for the information of everyone, these tests which we have done or various other institutes are doing, for example, Hamburg wheel rut test using steel wheel or rubber tire, ideal CT, name any test which we are doing. All these are surrogate tests, dynamic creep. They do not actually, uh, they will not, relate what is actually happening in the field. So these are surrogate measures, and we are just trying to identify based on these surrogate measures what appropriate value can be chosen to correlate to the field. It's not simulating, it's correlating. So there is a difference which we all should understand. So when we say that yes, confining state is not the same, it is true because these are surrogate measures. It will not say what is actually happening in the field.
Yeah. Yeah, I would like to answer a few questions. One by Mr. Vikas Thakkar. What are the air voids at the end of 3 to 4 years? At the end of fourth year, it was around 3.5 to 4%, two different stages of R1 and R2. Does it correlate with the proposed air voids at the end of design life of MS2? Yes. It was still having air voids of 3.5 to 4% at the end of fifth year or fourth year. It is still correlating with MS2. It didn't come below 2%. Then what is the recommendation of air voids at the end of construction? I think I mentioned this as a recommendation, which is 94% of GMM or 6% air voids. Then next question is from my friend Vishnu. How appropriate is to perform wheel tracking study? I think I mentioned to you because there was raveling in this section. We thought we'll conduct wheel tracking using rubber tire to see whether there is still raveling occurring. We could see that yes, there was in road section too. And it was interesting to see reduction of binder content and due to aging, lower molecular hydrocarbon got um, connected to higher molecular. Okay, it was reduced. And it was observed due to resulting of slipping of binder. No, that's why I was not. I was bit conservative in concluding this one. It was only at two sections we observed that there is a reduction, and mainly because of that, the fine aggregate, which is around 150 micron, having a more surface area coated with bitumen, got aged and then raveled. And we could see that fine aggregate onto the end of the road. I think if you observe in few of the road sections, you may find the same. That was one of the reasons. That's why when we sliced it, the binder reduction was on the top, not at the bottom. Then what is the relevance of evaluating rutting? I think you asked about G star by sine delta. I said there should be one parameter for as a reference. LA is still not a conclusive test. So we could not go into the tracking mode of evaluation. So we preferred G star by sine delta. Once there is a change in that LAS study and if once it streamlines, I think we will go that, I'll take that as a reference. Then one from my ex-colleague Manoj Shuklaji. The BC in the upper portion is decreased as per your findings, and it's quite interesting. It means over period of time, BC reduce the in bitumen will be observed. Can it be conclusive? I think Shuklaji, I mentioned this has to be taken with a pinch of salt. It is only two studies. Probably if I had done around 10-15 studies, I would have been very authoritative or even with authenticity, I would have said that yes, it will reduce. But we were a bit conservative. That's why I put only one slide on this. Though we observed and there were a lot of studies done, I am taking a back seat on this. It cannot be very conclusive unless we do it some more studies. But thanks for your questions. Thank you, sir. Thank you, Chairman.
Well, okay. There is a question. What is the correlation of USET to RTFO PAV by Professor Akshay Gundla? So we have found that USET is very well correlated with RTFO, short-term aging, but not with long-term aging. Especially if we go for higher aging period, let us say 60 hours or 40 hours, it's not well correlated. So ultimately now our study concludes that for long-term aging, PAV is better than the conventional USET procedure. But for RTFO, yes, USET can be very easily used. What are the perceived advantages of USET over the two established methods? Well, for RTFO, the only advantage is it's easier, easily available, and the conditioning can be done in a draft oven. Then the next question is by Bishwa Bikas Raut. What is the impact of aggregate type size on aging binder, and is it essential to quantify the same during the mixed design stage? Well, in this study, we have not looked at the impact of type and size, but I think it's better to place the question or the answer rather that the aging will affect on where the bituminous mix is placed in the pavement. DBM layers will be subjected to less aging in comparison to bituminous layers. Of course, the air void will play a critical role. More is the air void, more will be the aging in the binder. And the film thickness of the binder is very important here. So depending on the filler to binder ratio, the everything will change. If you have more film over the aggregate particles, the aging will be less. So these are the answer to these questions. Thank
Yeah.
you.
As usual, Chatraj sir writes very good questions. Thank you, sir, for your question. You are telling that raveling is taking place only on the top surface. How it can be related to air voids? I took two different road sections here, road 1 and road 2, which had higher air voids. The other one had relatively lower. So higher air voids, aging is higher, and that 150 micron bitumen coated material will try to be as brittle as possible. With the tire movement it is removed. So higher air voids, there is more of raveling than the lower one. And then the next question is, what is your recommendation initial air void? What should be the range? I said it should be around 6% air voids, 94% of GMM. And then practical observations as shown, and it's an appreciation. Thank you very much, sir. Thank you.
Heartiest congratulations to the authors for the excellent questions and answers. But I think we are exceeding the time limit given to us. And during the tea time, I think all these authors are available with you during the tea time. You can get hold of him on the stage itself. So heartiest congratulations and compliments to the authors and the audience, which took a very keen interest in these papers and asked multiple questions. Few questions which could not have been answered. I'll be handing over to the IRC Secretariat, and otherwise you can discuss with the authors. Thank you very much.
Thank you so much, sir. और अब हम इस सेशन के समापन की तरफ हैं और साथ ही साथ एक छोटे से शेर के साथ मैं इनवाइट करना चाहूंगी, क्योंकि छत्तीसगढ़ी लोग जो हैं वो अपनी आओ भगत के लिए, मेहमान नवाजी के लिए जाने जाते हैं खास तौर पे। पता नहीं आप लोगों ने अभी छत्तीसगढ़िया व्यंजन का लुत्फ उठाया कि नहीं। छत्तीसगढ़ यानी 36 प्रकार की भाजियां, 36 प्रकार की सब्जियां यहाँ पर बनाई जाती है, बड़े खास तरीके से बनाई जाती है। जरूर आनंद लीजिएगा, अभी हैं अब 11 तारीख तक। मैं शेर कह रही हूँ हमारे आज होस्ट के लिए, एक्चुअली छत्तीसगढ़ियों की तरफ से। हर गली अच्छी लगी, हर गली अच्छी लगी, हर एक घर अच्छा लगा, वो जो आया शहर में तो शहर अच्छा लगा। और इसी के साथ अब मैं बुलाने जा रही हूँ। नाउ आई वुड लाइक टू इनवाइट श्री BS बघेल जी, चीफ इंजीनियर PWD दुर्ग छत्तीसगढ़, टू प्रेजेंट अ बुके टू चेयरमैन एंड को चेयरमैन एंड ऑल द गेस्ट। और साथ ही साथ मैं बुलाना चाहूंगी LOS GS कश्यप जी को। बहुत स्वागत है सर आपका भी, हमारे मेहमानों का मोमेंटो के साथ, पुष्पगुच्छ के साथ स्वागत करेंगे। और BS बघेल जी लगातार कई रातों से सोए नहीं है और इस आयोजन को सफल बनाने के लिए लगातार प्रयास कर रहे हैं। इसी कड़ी में अब चेयरमैन डॉक्टर महेश कुमार, पास्ट प्रेसिडेंट IRC एंड फॉर्मर ENC हरियाणा PWD, जो कि कल सम्मानित भी हुए हैं लाइफ टाइम अचीवमेंट अवार्ड से। और इस 83rd एनुअल सेशन में जोरदार तालियां, एक बार पुनः बधाई। अब तो कई सारे लोग भी इस वक्त मौजूद हैं हमारे बीच, तो तालियों की गड़गड़ाहट ज्यादा आनी चाहिए। बाकी जो साइड में पंडाल लगे हैं, डोम बने हैं, उनमें आवाज जानी चाहिए। और साथ ही साथ ये यादगार पल के साथ ये सेशन बेहद ही शानदार रहा है। को चेयरमैन डॉक्टर UK गुरुविठल जी इस वक्त स्मृति चिन्ह और बुके से सम्मानित किए जा रहे हैं श्री BS बघेल जी के द्वारा। साथ ही साथ मैं बुलाना चाहूंगी डॉक्टर प्रवीण कुमार जी को। डॉक्टर प्रवीण कुमार और डॉक्टर निखिल साबू जी को। डॉक्टर निखिल साबू स्मृति चिन्ह और बुके से सम्मानित कर रहे हैं। मैं बुलाना चाहूंगी प्रोफेसर श्रीधर राजू जी को। साथ ही साथ मैं रिक्वेस्ट करूंगी प्रोफेसर अंकित गुप्ता जी से भी। बहुत धन्यवाद, बहुत शुक्रिया सर, आप लोगों ने अपना कीमती वक्त यहाँ साझा किया, शेयर किया, इसके लिए एक बार फिर से धन्यवाद। और ये था सेशन 7 और अब बारी है सेशन 9 की, जिसकी शुरुआत बस होने ही जा रही है।